So a little probability review here. I have a two-way table with some categorical variables. So one is gender, male or female, and the other is grade, A, B, or C. So those are categories people fall into in this particular population, in this particular sample, I should say. And I just want to answer some probability questions. And remember, proportions are probabilities. So we've been doing a lot with proportions, confidence intervals and hypothesis tests, and a proportion is related to a probability. It's got to be a number between 0 and 1. And we have to figure out what's favorable for the numerator and what's total for the denominator, and that shifts depending on the situation. So first question says, find the probability that a student was male. And again, this is problem number 4 from the final practice. That's it, find the probability a student was male. All right, so I'm gonna copy this into my notebook so I can scribble on it. Number 4 from the final practice. Probability a student was male. So that means I need to count the male students and then divide by the total because it doesn't tell me anything else to do. And so in this particular sample, there were 35 males and 82 total. And some questions allow you to just enter a fraction. Others, we'd have to calculate that as a decimal and then enter a rounded version of that. So just gonna get a calculator out.
I was saying, I noticed that it doesn't really say in the question if you want it in decimal point. Will the final exam give us more details on whether or not you want it in fraction or decimal, or in a question like that, are you going to accept both?
Yeah, it should say if I click on the problem. So let me find that question. Where it go? Right there. So if I click on the box here, it says enter a mathematical expression, which means you can enter basically anything you want that gives me a similar answer. So I could here just type 35 out of 82 as an answer, or I could whip out my calculator and get a decimal version of that. And since it doesn't reference decimal places, then I would probably do at least 5. So 4, 2, 6, 8, 3. Is what I would put in there. So if I didn't do the fraction, and again, since it accepts fractions, that's the best possible answer. Otherwise, it should accept, should I get that right again, 0.4268 3. 5 decimal places, and it's okay with it. If I tried to do less than that, like if I rounded only to 2 decimal places, it's probably going to freak out on me and say, ooh, I don't like that. Yeah, I didn't like that one right there. But the fraction would have been okay, 35 divided by 82. All right, next. So we have that one. Find the probability that a student was female and got an A. All right, so for this one right here, whip up my highlighter for a minute. The and, both things, I have to consider both the females and the A's at the same time because of the and. So I want to know of the females here, which of them got an A? And so in that case, it would be just this 20 right there. So for this one, I would have an answer of 20 out of 82 female students who got an A.
It's out of the total students, not the...
Yeah, the only time you change the total is if it says something like given or knowing or if. So we'll get to that in this last question here. We might as well do it since we talked about it. So here, I want to find the probability that a student was female given they got a B. Sometimes it's worded in if they got a B or knowing they got a B. Probability notation like that would be female is the probability I want. And the given knowledge here is basically just changes my denominator for me. So then I would look for the females who got a B. So that would be this group here. And then my denominator is just the students who got a B there. So that one right there would be 11 out of 24. So the knowledge changes the denominator. So that's the only time we change the denominator. If there's no reference to some knowledge, some if, some given, then we just use the total for the whole sample. And there was a formula given for that in the book. It said, find the probability of being female and having a B, and divide by the probability of getting a B. And the probabilities are similar to the counts. So I did it by finding the count of females who got a B, dividing by all the people who have a B. And so that's kind of the simpler version of it, I think. So the key with the given, if, or knowing is you have a new denominator. So let's see, so this one here should be 11 out of 24. We didn't do this one yet. So the third one, find the probability that a student was female or. The or means it could be one, the other, or both. So in plain language, that mathematical or, I could say and or is the way I would write that kind of in an English class. So female and or a C. So I'm gonna use a highlighter for that. Highlighter red. So let's see, I want females for sure. So I need all of the females. And then I also need the C's. And so I need all 4 of these numbers here to get my total. So 20 plus 11 plus 16 is 47. Then add on that additional 19. So let's see, 47 plus 19 is 6, carry the 1, 66. So the or tells me it would be 66 out of 82 for that one right there. So the and, basically you want the overlap of the 2 categories. And the or means grab them all, don't double count. So if I tried to say, oh, just take 35 plus 47, the problem with that right there is I would be double counting that 16. And the book went over a formula for how to deal with that. So alternative to the way I went about doing it in the table, the book's formula for the probability of female or getting a C is to get the probability of being female. That'd be the 47 out of 82. Add that to the probability of getting a C, that'd be the 35 out of 82, but you have to subtract the double count, which is an and that's that 16. So there are a couple of formulas, but we can kind of sidetrack those formulas by just knowing that if it's an or here, that I just want to grab all related numbers without double counting. If it's an and, I only want where they're overlapped. And if it's a given, if, or knowing, that changes the denominator. So those are the big ideas there.